Thanks everyone for joining us. I'm Don Kostelek with Vitruvian Planning. We're a consulting firm here in Boise, Idaho. We do a variety of active transportation and ADA transition plan work. And two of our nonprofit partners, Idaho Access Project, for which Jeremy is on the board, as well as Dana Gover, who's on the meeting today, and Cynthia Gibson, the soon-to-be outgoing director of Idaho Walk Bike Alliance. Solo advocate for now, as she says in here, have helped us with this and promote it. And thanks to some of you joining from outside of Idaho to learn about this. We started organizing this about 2 or 3 months ago, but realizing we've had a lot of infrastructure projects, not only in Boise, but across the country, especially in the wake of COVID, that is maybe challenging some of the typical paradigms we have when it comes to accessibility, especially making detectable features for people with vision disabilities. And so Jason Draper, who is with a company called StrongGo that manufactures a lot of these products, but more importantly, researches them. We just didn't want to call somebody on here to be a sales job, but really this is a company that is at the forefront of researching and testing these applications and has been a great resource for us on a variety of projects. So we'll get going here. I'll just have a couple of intro slides. So if Jason, you want to advance that. First of all, I want to dedicate this in memory of a longtime friend and colleague of mine, Janet Barlow. Janet, for a long time, was a researcher and orientation and mobility specialist for people with vision disabilities. And if you found any ADA-related research on detectable warnings and tactile strips and roundabouts, you're likely to find Janet Barlow's name. And unfortunately, Janet passed away a couple years ago and still has some research pieces being published with her partners, BZ Benson and some others. They did set up a scholarship fund in Janet's name with the orientation and mobility specialist. So if you'd like to make a donation to that, certainly welcome, but certainly somebody who inspired me and I consider a friend. Next slide, Jason. So why are we talking about this? This research piece in the top left was done through the National Center for Independent Living. And really the idea of tactile strips and tactile edging beyond the typical truncated dome is something that's been being applied in other countries for quite some time. But as we know, the public right-of-way accessibility guidelines in the US have been in draft form for almost 20 years. And my opinion is because of that, we have not even allowed some of the ADA-related applications to advance or evolve because that's been sitting there. So what do we mean by these? If you see in the top image, you will see these bar tiles of colors coming out from a curb ramp that if you're a person with a vision disability walking in a straight line, you don't know that there's a curb ramp to access the parking space to your right. So these strips provide a cue as you're traveling along the sidewalk to do that. The bottom image is an example where I know people with vision disabilities have challenges, and that's at roundabouts in terms of walking the pedestrian aisle around them and not knowing when that curb ramp is adjacent to them so they can cross the street. That's just one of the ways our infrastructure and the applications are changing. Next slide. Another example is in the application of diagonal curb ramps. So where the truncated domes do not provide directionality and can orient people toward the middle of the intersection. And while these are meant to be a last resort application out there, they do exist for lots of reasons. And as you can see, the application on the right in this example is orienting the bar tile so someone can stand on there and sense which direction they are to walk instead of perhaps following a misguided cue from the truncated dome to go to the middle of the intersection. And then finally, next slide, just all the application of NACTO and urban street design principles. There's a lot of these, including shared streets and what happened after COVID, that just simply aren't in ProWAG and the ADA standards, but we're realizing there's a need there. And in this application, this is a very recent project in the city of Boise, and thanks to the great folks at Ada County Highway District, CCDC, and the city of Boise, in putting these tactile strips out there and using them. So if a person with a vision disability finds themselves off the sidewalk and into the bike lane, they still have a detectable cue to know when the end of that bike lane is occurring and to not get into traffic. So that's a little bit of where we are. Again, thanks to Jeremy and Cynthia for promoting it through their organizations. And with that, I'll hand it over to Jason.
All right, just was waiting to get unmuted. Sorry about that. So yeah, my name is Jason Draper. I'm with Strongo Industries. We manufacture Techway tactile warning systems and have done so for the past really couple of decades. So, I mean, there are a few different manufacturers of tactile warning systems out there. We try to take a different approach to it by focusing more on the front end, the accessibility, kind of like what Don was saying, trying to be more involved with the forefront and the research to, build a better mousetrap, so to speak, to make sure that we are, really providing the best for pedestrians with low to no vision. The company initially started out also working on mining applications, so had to come up with durable material to basically cover outgassing in temporary mine shafts. And so that technology was brought over to create tactile warning systems, and thus Techway was born from there. And so since that time, we have manufactured different tactile warning surface indicators. First, obviously, the majority of those being detectable warning systems, then tactile direction indicators, and more recently, tactile warning delineators, which are the three TWSIs or tactile warning system indicators that we will talk about today. So, just trying to break it up into four different sections for you. We're going to talk about why tactile warning surface indicators are necessary, even though, Don gave a pretty good intro as to why they are important. We're going to talk about the different surfaces, detectable warnings, and TDIs and TWDs, and then finally just key factors to maintaining their functionality. So if we look at kind of a definition given by B.P. Benson, and we work a lot with them. Don was mentioning Janet Barlow. It's really because of their research, due to a lot of their research, that we actually exist as a company because of all they've done to further, these applications for this group of people. And so this definition is really have to give credit to B.Z. Benson. So in general, TWSIs. It's like three types of walking surfaces that are used to aid wayfinding by pedestrians who have low to no vision. Basically, they've all been researched, tested, and they have been found to be detectable and distinguishable, whether underfoot or by cane. And also, most importantly, not most importantly, but also importantly, that they are contrasting in terms of color contrast, whether it's dark surface with a lighter sidewalk or vice versa. And not only that, but they contrast with each other. So now that we got the intro out of the way, and by the way, I mean, I'm going to try and get through this so that we can answer questions at the end. But if anybody has a question, feel free to ask. I might not see it, obviously, because we're on Zoom, but I'm sure Jeremy will let me know if somebody does, and I'm happy to answer it.
Jason, this is Jeremy. I'll let you know if there's a question. And on each of these slides, if you could describe these slides just a little bit for folks who might not be seeing them, that'd be fantastic. I forgot to ask you, but that would be fantastic.
Sure, I didn't know that. That's thank you for letting me know. Okay, so the slide we're looking at here, we just got some statistics for you when it comes to pedestrians that are that have low to no vision, and in the background it's an individual with a cane standing on a detectable warning that's ironically the direction that it's facing is in the middle of the intersection, which is what we'll be talking about, and Don kind of mentioned. But some statistics for you from the Foundation for the Blind. 1 in every 10 Americans has some sort of visual impairment. I mean, most Americans retain some sort of sight that have these impairments. It's probably closer to 15 or 20% that are actually blind. But in general, the statistic of people that have some sort of visual impairment is expected to double by 2050. Every 7 minutes, somebody starts to lose their eyesight. And the reason that we do what we do, and I'm sure a lot of you do what you do, is that every pedestrian has the right to travel safely. And these applications are a way to provide that equalization. So it's important to note, again, that not all pedestrians with vision impairments have lost complete sight. A lot of them still, most of them actually still retain some sort of vision that can vary, from the 3 that you see here, whether it's overall vision loss, more of a central vision loss, or a peripheral vision loss, but there is still some sort of vision that's maintained. Although, as you can see, when you start to lose those aspects of your vision, a tactile, function becomes important, or, the last thing to go when you're, losing your vision are colors. So things that are contrasting can be very helpful. So these are some typical aids for pedestrians with low to no vision. So you can see there's, a dog guide here, a long cane, and it's a little bit different than a typical cane that you actually, would see that's used to aid for, walking, for kind of like a impairment to your legs. But these long canes are actually more suited for tactile guiding. You also see that there's a human sighted assistant that can also be present. But it's important to note that even with like dog guides, somebody still has to feel a tactile signal underfoot to know where they're going. And so you can see the note here. A lot of pedestrians travel unaided, and so they rely heavily on the structure of the street. I mean, I've heard many times that the sound of traffic acts as kind of a borderline for somebody that's that can't see. And so if a path is straight, if there's like a building line on one side, traffic on one, and the path is just continuously straight, that's a little bit easier to navigate. It's when you have changes of direction, when you have surface changes, all those things are difficult to navigate. And so it's important to note, when pedestrians with visual impairments are traveling, they're not always familiar with where they're going. And again, they often travel independently. There might be unfamiliar destinations, just like you or I can, we're going shopping in a new place, or we're taking our family to a different park. I mean, same rules apply. And so they have to navigate different streets, different intersections, different crossings. And that unfamiliarity, especially when the signals aren't consistent, creates potential hazards. And again, the general layout of the street can help sometimes, but again, it can also be confusing, kind of like that roundabout that Don was showing. I mean, when things aren't clear and they're also unfamiliar, when it's something that hasn't been traversed before, that creates a potential hazard. So when we're talking about creating tactile warning surface indicators for these pedestrians, Strong Industries in particular goes by these 2 standards from the ADA. Number 1, Title II, just talking about how we shouldn't discriminate against, basically anybody that has a disability shouldn't be discriminated against. We take that a step further to mean, this needs to be an operable working order, and it needs to be focused on the highest level of accessibility possible to not discriminate against these people, so that they have an equal chance to traverse safely. And in that same line of thinking, in Title III, making sure that what you put down, it's accessible and it works, but it maintains that functionality. So stays in operable working condition for, the lifetime of the project. In addition, these are some more requirements that really encourage us to focus on a higher level of accessibility. And I have to give credit to Don for sending these to me, some of which I'm familiar with, some I didn't know. We're talking about RO2, the use of alternative designs, products, or technologies that result in substantially equivalent or greater accessibility, usability than the requirements in this document is permitted. So there's nowhere that says, you shouldn't go the extra mile when it comes to accessibility. Nothing in these requirements prevents the use of designs, products, or technologies as alternatives to those prescribed, provided they result in substantially equivalent or greater accessibility and usability. The responsibility for demonstrating equivalent facilitation in the event of the challenge rests with the covered entity. With the exception of transit facilities, which are covered by regulations issued by the DOT, there's no process for certifying that an alternative design provides equivalent facilitation. All of these things are telling us that we, in whatever local community that we are in, have the responsibility to go for greater accessibility. So when we're talking about, tactile awareness surface indicators, it's not just anything. We can't just look at something and say, hey, that surface is different from that surface. It must be sufficient enough to put as a detectable warning or a tactile direction indicator. Because a lot of these surfaces, when they're felt underfoot or by cane, actually feel the same. You can see kind of in the middle, these groove curb ramps, that has been done in many parts of the country, or on the other side, just a different material, kind of like a gravelly surface. Either one of those are not sufficient enough. That doesn't indicate a whole lot of change, because there can be similar surfaces in the walkway that don't indicate anything. And on the left here, that's acting kind of as a tactile direction indicator. But unfortunately, the surface, while it is unique, isn't necessarily enough to signal what it needs to. And I mean, when we're talking about all this, it's almost like you need to be able to speak Spanish when like English is the mainstream. It's a whole different language when we're talking about tactile awareness surface indicators. And it's important to realize, okay, what's the message of what we're sending to this person? And is that message consistent across the board? It's not just one person's opinion that may have some sort of vision impairments, and you go by that. It's thorough testing, making sure that across the board, and I've heard BZ Benson, quantify 90% as like that's the metric. Most people, most of the time, that's what we're going for. Not just one person's opinion, not just somebody saying that looks like it will work, but actually thoroughly vetting whatever you're wanting to use as a tactile warning surface indicator. So some factors to remember for positive tactile warning surface indicators, these that have been tested and vetted. There's enough spacing between the devices. Basically, you're not slapping them together and really confusing somebody. It's equivalent of multiple people shouting at the same time. The raised elements are sufficient to be detectable, but not to be a hazard. And there's adequate width. And we'll talk about that a little bit later, but basically so that there's enough of the device installed so that somebody doesn't step over it or miss it completely. So when you're looking at the various tactile warning surface indicators, some 3 things to remember if you're putting these down or trying to figure out what to use. Your device, making sure that what you're putting down is detectable. And I mean, there's 3 main devices that you can use, but there's not a whole lot of standards for this. So again, if you're thinking of experimenting or testing, you want to make sure that whatever you're putting down is detectable and has been tested to be detectable by foot or cane. It's discriminable from other devices. It's safe and easy to traverse. And if it needs to, that it meets federal, state, local requirements. You want to make sure it's in the right location. So again, safe and easy to traverse, and it's the legally required location. Like you're not putting it in the middle of an intersection where nobody's going to go and you're just going to cause issues. Also making sure that whatever installation method you're putting it down, that it ensures that however long you want it to be there, that it will not discriminate, so that it's functional, and that it maintains an operable working condition so that it will function over time. So the TWSI that we're probably most familiar with, and the one that has the most standards behind it, are detectable warning surfaces. So again, a lot of these definitions are courtesy of Accessible Design for the Blind and also just general ADA standards. But so detectable warnings are a standardized surface in the 2010 88 AG, comprised of fronting domes built in or applied to walking surfaces or other elements to warn of hazards on the circulation paths. They're required by DOT at curb ramps and the edge boarding platforms. You can actually take that a step further. They're usually required in the public right-of-way, where any walkway will come across a vehicular way. So wherever there's a sidewalk or pedestrian walkway that will intersect or run parallel to a vehicular walkway, and there's nothing to stop it, like no curbs, no bollards, nothing to indicate a change of pathway, you need to have something that indicates that for people that cannot see or cannot see well. So taking it a step further, when somebody comes across this, it's supposed to be functioning like a stop sign. So they should think, okay, there's a hazard coming up, and I should really analyze where I'm at, because there's either a street or a platform edge or some sort of hazardous vehicular way that is coming into my pathway. So again, detectable warnings have the most standards behind them. This is the result of thorough testing. I mean, the ADA, Americans with Disabilities Act, came out in like 1991, 1992, and it had detectable warnings in the standards, but they were actually suspended for a while to do some more testing to really figure out what was best for this function. So after many years of testing, in 2001, they were released again. Or I should say the suspension expired, and so they were starting to be used. And kind of what you saw on the last slide, in 2010, they were really standardized. And so the sizing and spacing of the detectable warnings is very, very specific. You can see here there's, you've got 0.9 to 1.4 inches on the truncation, and it should be truncated on the top of that dome. Should only be 0.2 inches high, which is, that 0.2 is a pretty good metric for TWSIs as far as what we were talking about earlier, making sure it's a raised element to be detectable, but not too much to be a hazard. More than that, you've got, how far apart the domes need to be. So like, 0.65 spacing, center to center, the domes to domes. 1.6 is just a 2.4. Now, this sounds like a whole lot of boring regulation, but like I said before, it's a result of thorough testing to ensure that this is the adequate spacing and raised element enough to be detectable. And it's important in this aspect because it stops pedestrians from going out into the intersection, or at least stop and orient, what's going on, where am I at this point? So again, another important aspect that's federally mandated, somewhat vague, is dark on light, dark on light. General rule of thumb, you want to put a dark surface with a lighter concrete, and vice versa. There were more specific standards, but really it was hard to quantify those at different times of the day. So the federal standards left those pretty vague. So taking it a step further, like California, Caltrans and the California Building Code has like a 70% contrasting ratio. So if you take the actual light reflectance values of, say, the material versus the sidewalk, you can determine that, light on dark, dark on light ratio, and 70% is a pretty good metric. Again, at different parts of the day, it'll be a little bit different, but still it's a good benchmark to use. Something to note, if you're using federal yellow, which is a pretty recognizable safety color, In order to ensure that contrast, you probably don't want to put it in a lighter concrete, or if you do, you want to make sure that there's some sort of dark contrasting element that's between the material and the sidewalk. And that applies to any of the applications that we're talking about today. There needs to be some sort of contrast between the materials, because again, that's one of the last things that people losing their vision will see are those colors and that contrast. So you can kind of see a difference here. If we're talking about a lighter sidewalk, a federal yellow color is only going to get you about a 36%, unless you do something to enhance that contrast. Whereas a charcoal color or like a dark red color will get you a much higher percentage. But you also need to think, okay, charcoal, is that also going to be considered, like a whole? Because again, people can't see this very well. So color is super important when you're choosing what to use. And so when, please consider this. And we also have a color contrast tool on our website you're welcome to use, or if you have your own. Very important, especially if you're using multiple TWSI elements. And this is just some different examples of local jurisdictions that use different colors, not necessarily federal yellow, but still gets you that better contrast with the surrounding sidewalk. We'll just keep going through these requirements because they do exist for detectable warnings. So in general, per the DOT, the detectable warnings, number one, need to extend full width of the curb ramp, but not the flared sides. And they need to be 24 inches deep in the direction of pedestrian travel. And again, that's just to make sure that they aren't missed. So 24 inches is considered the minimum acceptable depth. They can be longer than that or bigger than that, but 24 inches is the minimum when we're talking about curb ramps or detectable warnings on these kind of surfaces, I should say. Just more to my point earlier, there is an actual standard that says if it's not separated by some sort of element and it leads into a hazardous vehicular way, you need detectable warnings to be there. And two great examples are curb ramps, where obviously the sidewalk is becoming flush with the crosswalk, and on transit platforms where you see, the platform edge, there's nothing to stop somebody from walking right off. So kind of like what we reviewed in those earlier standards, when it comes to, color or spacing, things like that, the federal government is going to offer its minimum guidelines. Sometimes the state takes an extra step, sometimes it doesn't. Like if you're going to Texas, they mirror the federal standards. If you're going to California, they take it a lot of steps further. But it really is up to the local jurisdiction. And a big reason for that is because what's best in your communities. Who is, what colors are going to be best for the environment, what spacing is going to be best, say, for somebody in a wheelchair, to make a compromise for that group with the visually impaired pedestrians. So it usually rests with the local jurisdiction. Of course, if it's like a state project or a federally funded project, that's a little different. An example of that is like the city of San Francisco. They actually have performance specifications embedded into their projects where they talk about using a specific material, polymer composite concrete. They like to use federal yellow, but they also darken the pigments of their curb ramps to enhance that color. And Caltrans actually specifies like a 2.3 to 2.4 spacing from the center to one dome to the other. They take it a step further to be 1.67, so closer together to ensure detectability. These are just some examples of different places where you're going to see detectable warnings, a lot of which you're probably familiar with, like roundabouts or blended transitions, crosswalks that go across a rail line, or boarding platforms, things like that. And again, I know I'm kind of blazing through all these, so if anybody has questions, please let me know. Okay, so next we're kind of going over to tactile direction indicators and tactile warning delineators. There's a lot less standards that are given for these, and in reality, there's not actually a solid federal standard. And so a lot of these things come down to the studies that have been done for them, how they've been used elsewhere, and just overall best practices. So when we're talking about tactile direction indicators, again, courtesy of accessible design for the blind, it's a surface comprised of raised, parallel, flat top, elongated bars indicating an unobstructed path of travel where there are no natural guidelines such as edges of sidewalks, walls, or curbs, and where other directional cues such as traffic may be missing. So these are not meant to be a stop sign. They're meant to be, you can continue on this safely. There's nothing to stop your path from going forward until you feel another cue or signal. So they're really meant for aligning, like you saw with Don's picture, to make sure that you're going in the right direction, or a long-term wayfinding tool that you can follow on either side without any danger of a vehicular way coming up. So it's very important that to understand that these are not meant to be a border. They're not to indicate danger. They're quite the opposite, to indicate safety. So if you proceed in this direction, you will be okay. So it's very important that that message doesn't get miscommunicated and they don't act as a border. If you go over this line, you're going to be in a vehicular way, because that's the wrong message. So there, I was able to find actually a better example of this on the Federal Highway Administration, and I've included the link in the end of the presentation if you want to see this, but there aren't a whole lot of standards when it comes to tactile direction indicators. And so this is kind of the universally accepted design that's used in the United States, making sure that you have adequate spacing between the 4 bars. Again, that those bars, back to that 0.2 inches, it's not too high of an element to be a hazard, but it's enough to be detectable. And again, this is from thorough testing done not only in the US, but also in different parts of the world, and most especially in Europe and Japan, where they have used these in tandem with detective warnings for many, many decades. So the 3 main scenarios that you'll see with tactile direction indicators are, number 1, guiding along a path as a wayfinding tool. So again, an elongated path where you're safe on both sides. You'll see them as an indicator of where to board or disembark on a vehicle, because you'll have those detectable warnings along the whole platform, but they don't necessarily indicate where you need to get on or off. So that's why on elongated transit stops, it's important to have that element so you know where the door is. Or like you saw with Don's picture, it aligns the direction of travel, because you can see on this, especially on radius installations, or just in general, detective warnings, I have been told are not exactly the best indicator of orientation. So, you step on a detectable warning with a bunch of those domes, it doesn't necessarily give you the best indication of what direction you're going. So these help by offering a clear message. That's the way to cross the street. Don't go this way or this way, because we know the detectable warnings are there, but that's where you need to cross when you're not in danger. And that's just the big thing that you need to remember with, these different TWSIs. Detectable warnings are a stop sign. These bars are direction indicators, or indicators of directional safety, I should say. So like on the left, you'll see plenty of space on both sides, easily navigating. There's no danger of a vehicle coming in here at any point in time. It's just guiding along a path because it's not necessarily a straight shot. On the right, that's where they're more acting like a boundary. So that indicates, they're supposed to indicate that there is safety on both sides, where in reality, there's a bike path on one side where a collision or some possible hazard could happen from that bike. Okay, so moving on, these are relatively new in the last probably 3 or 4 years, tactile warning delineators. So they're a little hard to see in these pictures, but it's this element by the bike and on the left side of this gentleman here. So it's a raised linear surface. It's a trapezoid shape as far as the cross section, and it delineates the boundary between a sidewalk and a separated bike lane. Basically where you see shared zones, either a bike path or a vehicular path on the other side. So in contrast to the tactile direction indicators, this does act like a border. You're not necessarily supposed to cross it. It can be if needed, say if somebody in a wheelchair needs to, or a scooter or some kind of wheeled vehicle needs to get over it. But in general, it's not meant to be crossed. It is indicating that you are at the same level as a hazardous path that you're running parallel along. And the ideal situation would be when it's safe to cross, there would be another tactile signal that would indicate that. So the background of these is there was a study conducted in the city and county of San Francisco, and this kind of goes back to what we were saying, like you can't just throw out TWSIs willy-nilly. They have to be studied and vetted, and they have to work for most people most of the time. So in 2019, this kind of a study was headed up by the city and county of San Francisco, really in relation to their Better Market Street project. A lot of local advocates were worked with on this project, including Beezy's group, the Accessible Design for the Blind, also the Lighthouse for the Blind in San Francisco, the bike groups, the mobility impaired groups. So a lot of different participants here, a good period for study. And they worked with, had the privilege of working with them on this just because we have been working with the city of San Francisco for a long time and for the Lighthouse of the Blind. And they tested 4 different surfaces to basically find a solution to what I was just saying, the bike path or the shared use path to act as a significant border that wasn't confusing with another device. So they did test the bars that you saw before, the truncated domes, this corduroy on the left, which is a design I believe is used in Europe, and the trapezoid. So a lot of different, like I said, a lot of different entities were involved, a lot of advocacy groups, with different circumstances, either with guide dogs, canes, sighted assistants, different departments from city and county of San Francisco were consulted in this. And they needed something that was detectable, that was distinct, it still had slip resistance, made sure that it was an ideal dimension for water flow, things like that, color contrast, a robust enough separator within that kind of limited real estate between the bike path and pedestrian path. And that you also, like I said, wheeled vehicles were able to cross over it. So they did a couple different tests. And again, the only reason I'm going over all this is to show you all the level of thoroughness that is involved with using a new device for a new application. There's a lot of vetting. It can't just be done willy-nilly and just say, okay, this is a different thing, it'll work. It has to be proven. So they did a detection test, an identification test, a following task, a crossing task. And you can see here, there was different elements of that, detecting the surface, making sure they can identify it from different angles, following the delineators along a long path, and then also crossing over them. So from there, the trapezoid here, and just for the sake of, understanding this, oh, sorry. Go back.
Right. Okay. They start on June. I think.
For the sake of understanding, the trapezoid here, you'll only see like the trapezoid shape that's actually going to be above the surface. There's a little bit of probably about 3/4 of an inch that's embedded in concrete. And that was the specific one that was used for San Francisco, but it was found to have a distinctive shape other than the other, different than the other devices that are used. And that shape was robust enough to basically act sufficiently as a border to say, you know, bikes can feel this and know not to cross over this, and vice versa. Pedestrians can feel this and know not to cross over into the bike lane. Overall, you know, they were better, and that's an actual statistic from the study that I included in there. They were better for detection, and obviously quick detection when you're talking about 12 inches wide is very important so that you don't get cane intrusions into the bike lane, which can cause obviously collisions or hazards. They were also, you know, found most effective in having detectability for multiple angles of approach. So, you know, different ways of coming at those delineators from different sides. And just overall, from the participants that had visual impairments, the trapezoids were overall preferred for their distinctive shape, their detectability, just overall between all the devices, and being like specifically for this purpose, that's how the trapezoids were chosen. And so these are just a little bit more measurements for you, so you can see kind of what's attached to the finite exactness of a tactile warning surface indicator. So these measurements are very exact, kind of like the detectable warnings and the bars, because that's what's been proven to be detectable and distinguishable. And just like the bars, just like the detectable warnings, they all come in different sizes, colors, applications. I only included the delineators here because they are a relatively new device. So you can kind of get an idea of how they can be used, whether on just a really long bike path or whether you have to break them up for streetscape elements, things like that. Okay. So now that we've covered the different TWSIs, I wanted to talk about, you know, maintaining the functionality of those. So going back to the beginning when we were talking about these need to be in operable working condition, you need to consider that when you're either working with or installing TWSIs, like what are they going to have to come against to be successful? Because again, these aren't light bulbs or doorknobs or nails that you throw in at the end of a project. These are federally mandated, and if not mandated, then important for this community of pedestrians so that they can travel safely. So in order to make sure that they can be in working condition, you have to consider these critical points. First of which being ADA compliance. For those materials that are compliant, or if there's any general compliance standards for them, it's important to know that and to abide by that, because obviously that's, you know, what's required to put them in. So, you know, going back to shape, dimension, spacing, color contrast, placing them in the right location, and maintaining functionality. These elements are usually outside all the time, having to deal with pedestrian traffic. That doesn't seem like a whole lot, but when you consider places that are in tourist attractions, hospitals, universities, well-traveled areas, you're going to see not only foot traffic, but you're also going to see vehicular traffic. You'll often see these in flush transitions from sidewalk to vehicular way, kind of like here, where a bus is parked over them. They need to be able to withstand those kind of things and repeatedly withstand them over time. Otherwise, they're not going to be in operable working condition. And so it's not only doing a disservice to the visually impaired community, but as the owner of the project or the jurisdiction, you're coming into liability issues and things to consider if these aren't continually working. Again, these are outside all the time. I mean, unless you're talking about, like, say, in LA Metro, the tactile direction indicators, most of the time, these different devices are going to be outside. So the local climate is something to consider. Like in Arizona, we have heat all the time, never stops. So, and it's not only the heat, but it's the constant ultraviolet exposure. It needs to be able to retain its color contrast. It needs to be able to stay solid with temperature swings. All of those things are important if you're in a place that has a lot of moisture, flooding, heavy rain. Don't know how much snow everybody gets in their different parts of the country, but that's also something else to consider. It's freeze thaw conditions and snow, making sure that they can withstand the effects of inclement weather. Lasting slip resistance is not only something to consider to serve a pedestrian who has vision impairments, but just overall because other people are going to be walking in this right of way as well. It takes up the whole curb ramp, exclusive of the flared sides, and goes into the crosswalk. So it needs to have lasting slip resistance. Otherwise, you're going to encounter hazards. So it's just something to consider, like things like plastic that are naturally slippery. They have different nubs, for lack of a better term, that are put onto them. And once they wear off, they become a slippery surface. Other materials also soak up the water that they use, and they deteriorate. So that slip resistance kind of goes out the window as well. And just in general, you're trying to maintain the raised element of these different devices so that they can, be detectable. So that brings us into the next one, having low water absorption. So making sure that whatever device you're using doesn't soak up the water, because if it has a sponge, that water is going to break it down. And also the installation, the substrate underneath, that can't soak up water either. Otherwise, the whole device is going to break down. Covered color contrast already, but it's, again, a big point to consider with whatever you're putting down. It needs to not only differentiate itself from the surrounding surface, but also from any other elements that you're putting into. Like if you're putting a detectable warning surface next to a tactile direction indicator, that needs to be separated. You need to make sure that you have a proven installation process throughout this, something that is simple. Ideally, you want something that's going to create a solid monolithic structure. So something that can really support the device above and is as maintenance free as possible. I mean, we live in a world where I can say that, but it doesn't always happen. But, you want it to be the least amount of maintenance possible so that it can maintain itself in operable working condition. So I just want to take a second on this. A proven installation that I've seen is, or that in our experience that we've seen, is one that ensures a monolithic installation. So the wet set or cast in place installation method is one that can do this. And that's one that you can use with most of these, or if not all of these tactile warning surface indicators. With a low material cost, simple installation process, the domes or whatever device you're using can be installed as the sidewalk is poured. And this really ensures a durable and permanent solution because you can create that support structure underneath the device. So that's what's really designed to withstand that heavy traffic and pedestrian traffic that we were talking about earlier. So this is more of just a note to consider when you're looking at, can this device survive these different elements? You want to look at the ASTM test data. So that'll tell you those critical things like compressive strength. Does it have the strength to withstand vehicles, heavy pedestrian traffic? Does it absorb a lot of water? Does it have high slip resistance? And does it have lasting slip resistance? So these ASTM data results will tell you that. So getting to the end here, I know I got to wrap up here pretty quickly, but I just want to end with these last couple of slides that really iterate. If you're neglecting the functionality of these devices, and this is why I wanted to cover this, you're neglecting safety and you're basically neglecting signaling to a visually impaired pedestrian of what what they need to do. So whether that's you're using the inappropriate device, like the bars as a border instead of a guidance tool, whether you're using inadequate material, like something that can't withstand heavy traffic or weather conditions, you're using incorrect color contrast, or just an inadequate installation. All of those things are a detriment to when you're trying to achieve greater accessibility. And in my humble opinion, legal compliance is not enough. Doing the minimum standard when it comes to accessibility is not enough. You need to focus on lasting compliance and better accessibility, because that's what does the right thing for pedestrians who have low to no vision. And so, yes, legal compliance, you can achieve that. It's the minimum local, state, or federal standards. But greater accessibility requires, you're really focusing on the material, the product, and the testing factors behind those products. You're analyzing the STM test data that we just talked about, best practices. You're talking with people that know how these are supposed to be used, like Accessible Design for the Blind or Dawn or anybody that is familiar with the best practices for these materials. Once you find these materials that you're recommending, products that give greater accessibility to the project owner, local jurisdiction, once you have that, you're protecting that product specification. And you can do that by using, performance specifications. I know or equal is a big thing, but you can at least put in there, you need to have this or equal. And it's not equated to doorknobs or nails or light bulbs at the end of the project. You've set forth the standard that it needs to have some sort of high standard to it, because this is for this group of people to help them traverse safely. And in doing this, you're ensuring reliability to the project owner, your jurisdiction, and the visually impaired within that community. So that's all I have for today. Hope nobody fell asleep, but this is important to my company, and I'm sure to a lot of you, because this is for the sake of people traveling safely. And so if anybody has any further questions, you can feel free to call me. I've listed some websites here that you can use, including ours, for reference. But that's all I have. I can turn it back over to Jeremy and Donna if anybody has any questions.
Hey, Jason, this is Jeremy. Thanks for that. I just wanted to make sure you caught a comment in the chat box. It says, you may get to it, but we have a standard in regard to truncated domes. For example, dome spacing. How, as an entity, are we to distinguish what falls under the ADA guidelines with the quote wayfinding surfaces? I think you touched a little bit about that, but if you can just maybe expand on that.
Yeah, so spacing is pretty similar. I can send this link. Let me send it in the chat. So this is actually an FHWA standard. So that relates to, it needs to abide by, I think it's ISO standards to be detectable. So I can just send that. So if you follow those guidelines, it should be able to help you make sure that the bars are spaced enough. Most manufacturers in the US will use typical spacing, and I can actually, I should have one at my desk, but I believe it's 2.4 inches. It is the correct spacing. But I can verify that. But following that link will kind of take you to the generally accepted guidelines set forth by the FHWA. Any other questions?
This is Jeremy again. I guess I would, I don't see any other questions in the chat, but I would ask, I know our county highway districts are certainly going through this, but what have you seen in terms of the diverse options for tactile indicators and wayfinding? How do you see municipalities, agencies dealing with the changing landscape? Because you don't want to be, taking the latest, greatest thing every week and going out there and putting it into projects. That's not helpful for predictability. But I'm curious if how do agencies that both have to be predictable and manage projects and purchasing and ordering, how does in design review and all that, how do they engage with this when things change?
Right. Well, I mean, a big thing to note is that, there aren't necessarily nationally recognized standards for the two tactile warning surface indicators that we talked about today, just detectable warnings. So that is a concern that's shared by many of the people that we talk to. And so when you're looking at, I mean, a big thing to note is that there are like 3 generally accepted tactile warning surface indicators, in the past 30 years. And so when you're looking at what to use, like I said, contacting the resources that are available to you, people that are familiar with different accessibility standards, making sure that there's a thorough testing or vetting behind what is used. It's also helpful to look at what other jurisdictions have used, but not necessarily the end all be all, because they might be using something for not its best intended use. I mean, I would also try and find who is the leading authority on it. Like I know Don does, and we do as well, work with Accessible Design for the Blind, and BZ Benson is actually somebody that was instrumental in bringing detectable warnings, those standards from Europe or Japan, and bringing them to the United States. So that's a good resource for you. But just research is key when you're trying to find out what is best to use. Right now, there are 3 generally accepted surfaces, but there are constant studies going around. So I would probably say your best practice is to find the most leading authority that you can on what to use, and make sure that you're consulting them when you're trying to explore different options.
Thanks.
Hope that helped.
Yeah, and then one last question in the chat. Are there drainage concerns with the trapezoidal devices? Do they have to be installed in a certain way to prevent damming?
Yeah, so that was actually a concern that was shared. I'm trying to get back to it. By the city and county of San Francisco. And so you can't see it very well, but what we actually did was there's a little sliver between the trapezoids. You can't really see it here, but there's a little sliver right here that was meant to be a drainage spot in between the two, but that necessarily isn't adequate if you have a lot of moisture or pooling that happens. And so this is why I put this here. So this is why you can space them out a little bit. I mean, it doesn't necessarily have to be that wide, but you can space them out to allow for more drainage, depending on the length of whatever your vehicular way is. But as long as there's something, some part there that you can navigate through and that can be drained, that should be okay. Just spacing them out a little bit for drainage.
Okay, thanks for that. Don, I'm going to hand it back to you.
Yeah, thanks, Jeremy, and thanks, Jason. Thanks to the 30 or so that were able to join us for the hour. We're going to get out of here with your time. I think you got Jason's email and certainly Jeremy's. If you just Google like tactile warning strip indicators or TWSIs, you'll see some of the BZ Benson and some of the other research that's been done out there. If you'd like more specific links to that, just reach out to one of us and we'll be happy to send them to you. Thank you.
Thank you all for your time.
Thanks, Jason.